Okay, let's move on to white sheet. So essentially in this problem, we're given three sheets of rectangular paper. One is a white sheet and there are two black sheets. And we first place down this white sheet of paper, and then afterwards we place these two black sheets of paper. And then in the end, we want to see if these black sheets of paper fully cover this white sheet of paper that we placed down first. The key things is that all rectangles will be parallel to the x and y axis, and that for each rectangle, the input, we're given the bottom left and the top right corner. So the first thing to notice is that the bounds for the x's and y is pretty high. It's to 10 to the 6, which means in theory we could have a square with a height of 1,000,000 and a width of 1,000,000, which means that the total area of the square would be 10 to the 12. And that means that we can't have a O of n answer where we go through each point one by one, and we check if it's part of the white square and not the black square. So I've actually just solved this problem because I got it accepted, but there was an audio issue. So I'll just go through my thinking. So the first thing to notice is that if you just look at this example, what we can do is we can look at the area of the white square, and then we look at the intersection with the white squares with the white rectangle, sorry, with the black rectangles. And if that area of intersection is bigger than the is as big or bigger than the total area of the white rectangle, then we know that the black rectangles fully cover the white rectangle, right? So in this example, if you look at the intersection between the white rectangle and the black rectangle, so that would be the sum of this area and this area. But this area is clearly smaller than the total area of the white rectangle. So if we do a simple subtraction of the area of the white square minus the intersection of the white square and the and of the white rectangle and the first black rectangle minus the intersection of the white rectangle and the second black rectangle, and we'll see that clearly this is bigger than 0. And so that is the first thing that we notice. But there's also one more case that we need to take into account, which is this. If there is an overlap with of all three rectangles as shown here, then we need to also add the intersection of the area between the white rectangle and both black rectangles. Why is that? Because this area is counted twice. It's counted in this subtraction and in this subtraction, which is not what we want. We only want to take this into account of as the intersection between the white squares and black squares only once, not twice. So we need to add this back again. And then when we do, it works. So the first thing that we have to do is we need to change the function for the area of intersection to find it between more than two rectangles. So the way you do that is the points you're looking for are here, are essentially the rightmost left point, the leftmost right point, the highest low point, and the lowest high point. Why is that? Because if you take a look at this example, and in here we know for sure there is some intersection, which is going to be the area of this rectangle. So what we can do is we need to find the height and the width. So the way we can do that is we can actually find these points here. And so over here we just find the leftmost right point, the rightmost left point, the highest low point, and the lowest high point, because those points are for sure going to be in all three rectangles if there exists some overlap. So then we do that, and then we have to do this. The reason we do this is in the case there is no overlap between all three rectangles, then either this or this is going to be 0 or less than 0. And we can't have a width or height of less than 0. So we just set the here we'd set the width as 0, or in this case we'd set the height as 0, and this ensures that we output that the area of intersection, sorry, is 0. So then it just, we create 3 rectangles. We read in the white rectangle, we read in the then we read in both the black rectangles, and then we just follow this formula. We look at the total area of the white rectangle minus the intersection between the white rectangle and both the black rectangles, and then we add the portion that is subtracted one too many times in this subtraction. And then if this sum is bigger than 0, we output yes. If not, we output no. And then this works. So yeah, I think the key thing is just to find this case where both the black rectangles overlap within the area of the white rectangle, and then we just have to take that into account. So yeah, and this works as shown here. So voila.